Ever wondered what could potentially halt our journey to the stars? It might surprise you to know that it's not aliens or a lack of technology, but space junk. Yes, that's right, space junk. It's the silent enemy of our cosmic ambitions, loitering around in Earth's orbit. This floating detritus, remnants of old satellites, spent rocket stages, and fragments from disintegration, erosion, and collisions, poses a serious hazard to our spacecraft and satellites. Just picture this. A minuscule screw, traveling at a speed of thousands of miles per hour, could potentially cause a disaster on a multi-million-dollar satellite. These high-speed impacts not only damage the precious equipment, but also generate more debris, setting off a dangerous chain reaction. Now you might be asking, what exactly is space junk and where did it all come from? To understand the problem, we need to dive into the past. The history of space junk begins with the dawn of the space age, in the late 1950s. The launch of the first artificial satellite, Sputnik, by the Soviet Union in 1957 marked the start of our journey into the cosmos. But along with this milestone came the first pieces of space debris. In the early years, space was a wide-open frontier, and the concept of space junk was virtually non-existent. But as we continued to explore, the number of objects in orbit began to grow. Spacecraft, spent rocket stages, defunct satellites, and even tiny fragments of these objects started to accumulate. The first recorded incident of space junk causing damage happened in the late 60s, when a tiny piece of debris hit a US satellite, puncturing its solar panel. This incident served as a wake-up call to the potential dangers of space debris. Fast forward to the turn of the millennium, and the amount of space junk had grown exponentially. Today, it's estimated that there are millions of pieces of space debris orbiting Earth. This includes everything from tiny flecks of paint and bolts to entire defunct satellites and spent rocket stages. The rate of space launches has increased significantly over the years, especially with the advent of private space companies. While these launches have opened up new possibilities for exploration and communication, they've also contributed to the accumulation of space debris. As we've pushed the boundaries of exploration, we've left a trail of debris in our wake. This cloud of space junk now poses a significant threat to our satellites, space stations, and future missions. The history of space junk serves as a stark reminder of the consequences of our actions. As we continue to reach for the stars, we must also take responsibility for the mess we've made. As we can see, the problem has escalated over time, and it's high time we address it. Our future in space depends on it. The danger of space junk doesn't stop at potential collisions. There's a much greater threat lurking, a cascading disaster known as the domino effect, or more scientifically, the Kessler syndrome. Named after NASA scientist Donald J. Kessler, who first proposed the theory in the late 70s, this effect presents a catastrophic scenario that could make space exploration and satellite operation near impossible. Here's how it works. Imagine a piece of space debris colliding with a satellite. This isn't just a single event. The impact generates a cloud of new, smaller pieces of debris, each one a potential bullet speeding through space. Now these fragments can in turn collide with other objects, creating even more debris. The cycle continues, a chain reaction that exponentially increases the amount of junk in space. With each collision, the risk of further impacts grows. This isn't just a theoretical scenario either. We've already seen it happen. In 2009, a defunct Russian satellite and an operational American Iridium satellite collided over Siberia. The impact created thousands of pieces of debris, significantly increasing the risk of further collisions in that region of space. Now, bear in mind, space is vast, but the area around Earth where we operate satellites and conduct most of our space exploration isn't. It's becoming increasingly crowded. And with every new satellite launched, we're adding to the potential for a Kessler syndrome event. The worst-case scenario? A dense cloud of debris that makes certain orbits unusable, effectively walling us off from space. It's a chilling thought, isn't it? So the problem is not just the existing junk, but the potential for creating even more. The domino effect of space debris is a ticking time bomb, and we're the ones holding the detonator. It's not just about cleaning up what's already there, but also preventing new debris from being created. As we look towards a future among the stars, we must first ensure we're not trapping ourselves on our own doorstep. Now you might be wondering, so what? What if there is a lot of space junk? Well, let's dive into that. Firstly, we need to understand that this isn't just about having a cluttered closet that we can simply close the door on. In space, even the smallest fragments can cause catastrophic damage. Picture a tiny bolt, no bigger than a thumb, hurtling through space at speeds over 17,000 miles per hour. At such velocities, it has the potential to obliterate a multi-million-dollar satellite upon impact. Satellites are not just expensive pieces of technology, they are the backbone of our modern society. They facilitate weather forecasting, GPS navigation, television broadcasts, and countless other everyday services. A single damaged satellite could disrupt these services, causing widespread inconveniences and economic losses. But the implications go beyond earthly concerns. Space debris can also endanger astronauts aboard the International Space Station. These men and women are our pioneers, exploring the frontiers of space and expanding human knowledge. The risk of a space junk collision threatens their safety and could potentially halt manned space missions. Moreover, the accumulation of space debris could hinder our ability to explore the cosmos. The growing cloud of junk in Earth's orbit could create a barrier, making it increasingly difficult to launch spacecraft without the risk of collision. Imagine a future where our journey to the stars is blocked by the remnants of our past endeavors. How ironic would that be? Lastly, there's a long-term concern. As collisions create more debris, we run the risk of a chain reaction, where the density of space junk becomes so high that it triggers continuous collisions, rendering certain orbits unusable. This scenario, known as the Kessler syndrome, is a bleak prospect for the future of space exploration. Clearly, space junk is not just an inconvenience, but a significant threat. It's a ticking time bomb in our orbit, a problem we created, and one that we need to address before it's too late. The situation may seem dire, but all hope is not lost. Yes, the peril of space junk is real and daunting, but we're not helpless. There's a constellation of solutions being explored by scientists, engineers, space agencies, and companies worldwide. These potential remedies range from innovative technology to stringent regulations on space debris management. Firstly, let's talk about the technological measures. Picture a net, but not one you'd use for catching butterflies. We're discussing nets designed to snare space debris. The concept is simple, yet the execution is far from it. These nets, deployed from spacecraft, are designed to capture floating debris. Once the junk is snared, it can be safely deorbited and burned up in Earth's atmosphere. Then there's the laser solution. Not as far-fetched as it sounds, lasers could be used to zap the debris out of orbit. The idea is to use ground-based lasers to change the path of the debris, nudging it into a trajectory that leads to its fiery demise in the Earth's atmosphere. But technology alone can't solve our space junk problem. We also need to set rules and regulations for space debris management. For instance, guidelines could be established for the end-of-life disposal of satellites to prevent them from becoming future debris. Now, who's working on these solutions? Well, many space agencies and companies are actively researching and initiating projects to combat the space junk problem. The European Space Agency, or ESA for instance, has an active debris removal initiative in place. They're not alone. NASA, too, is heavily invested in research and development to tackle space debris. Private companies are also stepping up. For instance, Astroscale, a company based in Japan, is pioneering efforts in active debris removal. They're developing spacecraft equipped with magnetic plates to capture defunct satellites and safely deorbit them. And let's not forget the role of international cooperation. Space is a shared frontier, and the space junk problem is a shared responsibility. International collaboration is crucial in addressing this issue. In this regard, the United Nations Office for Outer Space Affairs is playing a key role in promoting international cooperation in the peaceful uses of outer space. While these solutions are promising, the task is monumental and requires collective effort. It's not just about cleaning up the mess, it's about changing our approach to space exploration and usage. It's about ensuring that we can continue reaching for the stars without the looming shadow of space junk threatening our journey. So what can we do to contribute to solving this problem? Well, each of us in our own way can play a part in combating the space junk crisis. It starts with awareness. By understanding the severity of the problem, we can help spread the word about the dangers of space debris. Discussions, debates, and dialogues can go a long way in bringing this issue to the forefront. Knowledge is power, and the more people know about this issue, the more pressure there will be on those with the ability to make a difference. Supporting space agencies and companies in their initiatives is another critical step. These organizations are at the forefront of developing solutions to tackle space junk. By endorsing their efforts, whether through donations, participating in their programs, or simply by following and sharing their work, we can help advance their cause. Moreover, we can advocate for regulations aimed at managing space debris. As it stands, the space industry is somewhat of a Wild West, with few laws governing the launch and disposal of spacecraft. By pushing for stricter regulations, we can ensure that future missions are conducted in a way that minimizes the generation of more space debris. Let's not forget, this is not just about protecting expensive satellites or ensuring uninterrupted GPS signals. This is about safeguarding our ability to explore the cosmos. It's about preserving the awe-inspiring beauty of the night sky for future generations. It's about ensuring that humanity's reach extends beyond the confines of our planet without being hampered by a cloud of floating junk. Remember, the peril of space junk is not a problem for a distant future. It's a problem for right now, and it's a problem that we all share. But together, we can turn the tide. Every journey begins with a single step, and every effort counts in our quest to keep space exploration safe and sustainable. We've come a long way in our journey to the stars, but the road ahead is filled with challenges. The peril of space junk, a silent enemy, is a pressing issue that can no longer be ignored. Orbiting our planet at incredible speeds, these fragments of debris pose a significant threat to our astronomical assets and future space exploration. The history of space junk has taught us that every launch, every mission, contributes to the problem. The domino effect of collisions creates a cycle that further exacerbates the issue. The consequences are dire, but there is hope. Inventive solutions are in the works, from debris-catching nets to orbit-zapping lasers. These innovations, however, need the collective support of space agencies and companies worldwide. The stars are within our reach, but only if we make sure our path is clear. Join us in the next video as we explore more about the universe we live in.